Hi all, let's start mathematics, grade 6, chapter 9, symmetry. Learning objectives. After this session, learners will be able to analyze the angles of rotational symmetry in given shapes. Let's recap rotational symmetry. This is the original position of a circle. If we rotate it of 90 degrees, this is this picture. If we after 180 degrees, it appears similar. After 270 also similar. After 360 degrees rotation also similar. We say that circle has a rotational symmetry. The definition of the rotational symmetry, the angle of symmetry is an angle through which a figure can be rotated to look exactly the same is called as an angle of rotational symmetry or just an angle of symmetry for short. So here the given figure has 4 angles of symmetry. Symmetries of a circle. The circle is a fascinating figure. If we observe here, how much ever we rotate it of this one, it will coincide with the original position. What happens when you rotate a circle clockwise about its center? It coincides with itself. It does not matter what angle you rotate. It's like 1 degree, 2 degrees, 3 degrees till 360 degrees. It's so for every circle, every angle is an angle of symmetry. Figure it out. Question number 1. Color the sectors of the circle below so that the figure has 3 angles of symmetry. Second subsection, 4 angles of symmetry. And third one, what are the possible numbers of angles of symmetry you can obtain by coloring the sectors in different ways? Solution. Let us see 3 angles of symmetry. If you observe, this circle has 3 angles of symmetry. Observe this next circle here. See, this is 4 angles of symmetry. The possible number of angles of symmetry are here. 2 angles of symmetry, 3 angles of symmetry is possible, 4 angles of symmetry is possible, and 6 angles of symmetry is possible. Figure it out. Question number 2. Draw 2 figures other than a circle and a square that have both reflection symmetry and rotational symmetry. Solution. An equilateral triangle with equal sides and a regular hexagon are examples of figures that have both reflection symmetry and rotational symmetry. If we observe here, if we reflect that this triangle, it will exactly look similar. Similarly, hexagon also, it will look similar. Similarly, if we rotate triangle by 120 degrees equilateral triangle, it has this similar. Similarly, hexagon also, it has this rotational symmetry. Figure it out. Question number 3. Draw, whenever possible, a rough sketch, a triangle with at least 2 lines of symmetry and at least 2 angles of symmetry. B. A triangle with only 1 line of symmetry and not having a rotational symmetry. C. A quadrilateral with rotational symmetry but no reflection symmetry. A quadrilateral with reflection symmetry but not having rotational symmetry. Solution. A triangle with at least 2 angles of symmetry and at least 2 angles of symmetry is as shown in figure here. This is a triangle here. See, this is a 1 line of symmetry. This is second line of symmetry. This is third line. So it satisfies the condition at least 2. The angles also. If we observe here, like this can be rotated 60 degrees or 120 degrees or 360 degrees. A triangle with 1 line of symmetry but not having a rotational symmetry is an isosceles triangle with 2 equal sides. If these 2 sides are equal, then it has 1 line of symmetry. But it does not have a rotation. After rotating this one, it is not similar to the original picture. A quadrilateral with a rotational symmetry but not a reflection symmetry. See here, if you observe the parallelogram, it has this, with a rotation of 180 degrees, it looks like a similar. But it's not, is this reflection symmetry. A quadrilateral with a reflection symmetry but not having a rotational symmetry. See here, this we can have this reflection symmetry by, but not this is rotational symmetry. Figure it out. Question number 4. In a figure, 60 degrees is the smallest angle of symmetry. What are the other angles of symmetry of this figure? Solution. See here, if 60 degrees is the smallest angle of symmetry here, then the other angle of symmetry are 120 degrees, 180 degrees, 240 degrees, 300 and 360 degrees. The figure likely represents a regular hexagon which has this rotational symmetrical angles as shown in the see here. This is the 60 degrees, 120 degrees, 180 degrees, 240 degrees, 300 degrees and 360 degrees. Question number 5. In a figure, 60 degrees an angle of symmetry. The figure has two angles of symmetry less than 60 degrees. What is its smallest angle of symmetry? Solution. It's a given that the known angle of symmetry is 60 degrees. So the divisors of 60 degrees are 1 degree, 2 degrees, 3 degrees, 4 degrees, 5, 6, 10, 12, 15, 20, 30 and 60. So if we observe here, since the figure has exactly two angles of symmetry less than 60 degrees, the only possible angles of the symmetry 20 degrees and 30. For example here, if we repeat the 15, then it may again coincide with this 30 and 60. So the possible angles are 20 and 30. So the smallest angle of symmetry is 20 degrees as shown in the figure. If you observe, this is angle of 20 degrees symmetry. Question number 6. Can we have a figure with rotational symmetries whose smallest angle of symmetry is 45 degrees or 17 degrees? Solution. Yes, a figure with rotational symmetry having the smallest angle as a 45 degrees is possible because 360 degree by the 45 degree is 8, which is its natural number. With 17 degrees, no, a figure cannot have a rotational symmetry with the smallest angle of 17 degrees since 360 is not divisible by 17. Let us see question number 7. This is a picture of new Parliament building in Delhi. Does the outer boundary of the picture have reflection symmetry? If so, draw the lines of symmetry. How many are they? Does it have a rotational symmetry around its center? If so, find the angles of rotational symmetry. Solution. First one, yes, the outer boundary of the picture has a rotational symmetry. It has a 3 lines of symmetry. Second one, the figure has a rotational symmetry around its center. The angles of rotational symmetry are 120 degrees, 240 degrees and 360 degrees. See, the first one is original picture. The second one is 120 degrees. The third one is 240 degrees. The fourth one is 360 degrees. Let us see question number 8. How many lines of symmetry do the shapes in the first shape sequence of chapter 1? Table 3, the regular polygons have. What number of the sequence do you get? Solution. If we observe from the chapter 1, table 3 is here. So now we need to prepare like these are all the regular polygons. So how many lines of symmetry? Let us see here. If we observe a triangle have this 3 sides and the number of lines of symmetry are 3. One is this first line, second line and third line. Similarly for the quadrilateral there are 4 sides. So it's a square exactly. So first line, second line, third line and fourth line. So these are the 4 lines of symmetry. Similarly for the pentagon we have 5 lines of symmetry. First line, second line, third line, fourth line and fifth line. If we observe, triangle has 3 sides, 3 lines of symmetry. The square has 4 lines of symmetry. And this pentagon has 5 sides, 5 lines of symmetry. Similarly, hexagon has 6 sides, it has 6 lines of symmetry. Similarly, heptagon 7 sides and this number of lines of symmetry is 7. Similarly, octagon 8 sides and 8 lines of symmetry and nonagon 9, decagon 10, 10. For example, I am drawing here with a triangle. This is a square, this is for this pentagon. So from the above table, the number of sides in a regular polygon equals the number of lines of symmetry. So the number sequence is 3, 4, 5, 6, 7. Let us see question number 9. How many angles of symmetry do the shapes in the first shape sequence in chapter 1, table 3, the regular polygons have? And what number sequence do you get? Observe here. This is regular polygons we do have. Let us take the first triangle. If we rotate this one, we are going to get is 120 degrees, 240 degrees, next 360 degrees. So if you observe here, the angle of rotation is 120, 240 and 360. So here for the triangle, the number of angles of symmetry is 3. Similarly, for quadrilateral, the number of angles of symmetry is 4. The first one is the 90 degrees, second one will be 180 degrees, third one will be 270 and the fourth one is 360. Similarly for pentagon 5, hexagon 6, heptagon 7 and octagon 8. From the above table, the number of sides in a regular polygon equals the number of angles of symmetry. So the number sequence is 3, 4, 5, 6, 7 and so on. Let us see question number 10. How many lines of symmetry do the shapes in the last shape sequence of chapter 1 table 3, the coach snowflake sequence have? How many angles of the symmetry? If we observe here, this is examples of the sequence. In this one, the coach snowflake sequence is the last one. In this last one also, we need to pick up this figure because the last shape. The coach snowflake has 6 lines of symmetry as shown in the figures. If you observe here, this is the first line of symmetry, second line of symmetry, third line of symmetry, fourth line of symmetry, fifth line of symmetry and the sixth line of symmetry. Let us see question number 11. How many lines of the symmetry and angles of symmetry does Ashoka Chakra have? We know that Ashoka Chakra has 24 lines. So let us see here. If we observe, this is the repeated here. 1, 2, 3, 4, 12. Then remaining again 1 is this. When you come here, this one, this will become this 13, 14 like that. So the Ashoka Chakra has 24 spokes spread equally. These 24 spokes form 12 pairs of opposite spokes. So here 1 will become this 13. So this is 13, then 14. Like this, if we keep on coming, this will be 24. A line drawn through opposite pair of this is symmetry. Line of number. Line 1 is this line of symmetry. Similarly, line 2, line 3, line 4, line 5, line 6, line 7, line 8, line 10, 12. Therefore, the Ashoka Chakra has total 12 lines of symmetry. The smallest angle of rotation symmetry is 360 divided by 24, that is 15 degrees. Thank you.